So we're going to work on multiplying now. Think back to when you had fractions and you learned how to multiply them. So maybe you had 12 over 7 times 49 over 15. And someone taught you at some point, oh, 3 goes into 12 4 times, 3 goes into 15 5 times. But sometimes we'll call this cross-canceling. 7 goes into 7 once, and 7 goes into 49 7 times, something like that. And then we would get 4 times 7 over 1 times 5, and then you just multiplied and had 28 over 5. So that's how we did it when we had numbers, just constants in there. I want to point out that when you have something like 12 over 15 times 33 over 7, something like that, you can cancel the 12 and the 15. Sometimes people think, oh, they have to be across from each other, but they don't have to be. You just have to have one in the numerator and one in the denominator. So, and then you'd get some answer here. Anyway, some big old answer. Okay. So I just wanted to point that out. All right, so here comes an example then with rational expressions. So what we're going to do is in multiplication, you're going to have a numerator, a numerator, and a denominator. And you're going to want to get them all factored and then see what you can cancel. Okay, so my first numerator, well, oops, sorry about that. My first numerator wanted to fly around. Okay, my first numerator is just 5 times x. Now you could write 5 dot x if you wanted to. That might make it easier to see. But those are each factors. 5 is a factor, x is a factor. Okay, in the denominator here, the first denominator, that's going to factor. So take a minute, stop the video, do the factoring, come back when you're done. Anyway, I'm going to go ahead and factor it. So x plus 2 times x plus 3. And that's how that one factors. I can double check. 2 times 3 is 6, and 2 plus 3 is 5. All right. Then I go to the second numerator. Well, that's the difference of squares. So it's going to factor into x plus 2 and x minus 2. Now in the denominator, you could write 10x. That would be okay. Or you could write 2 times 5 times x. Break it down into that prime factorization. It might be easier to see that way. So I would put the dot back in between the 5 and the x. Okay, now I'm not recopying these polynomials and factoring them that way. The more complicated ones I would do that way. And you can always write them out separately and factor them and then put them back in. But if you can kind of see what they are, then you don't have to. All right, I'm ready to cancel factors. So probably, the one that sticks out maybe is the x plus 2. Those are out. But you can also cancel this 5. And you can also cancel the factor of x. So that's all the stuff that gets to cancel. So now I look in the numerator. I don't want to miss anything. Looks like I have an x minus 2 with or without parentheses. They're not necessary because we're not multiplying it times anything. But then in the denominator, see how I have that little factor of 2 there? You're going to want to write that first. And then 2 times x plus 3, that binomial. That's how I would write the answer, and I would be done. Now, since this is a video, I have to try to guess at what some of your questions might be. Could I cancel the 2's? Like that 2 there and that 2 up there, could I cancel those? No. 2 is a factor in the denominator, but not the numerator, because it's x minus 2, so it's either the whole thing or you don't get to take part of it. You don't get to take that 2 away from the subtracting situation. Could I cancel the x's? No, for the same reason. In fact, x isn't a factor in the numerator or the denominator. So, okay, those are all the questions I can think of. Maybe you're asking, well, why didn't you put parentheses around here? You could, and that might make it a little easier to see what's going on. Okay, that's all I can think of.